With this sort of question, it's worth just having a look at where you're starting from and where you're going to have to end up. What's the difference? Well, the difference, this is now one term with a common denominator of both the separate denominators in this expression above, which are two terms separated by a minus sign. Now, for those of you who've not done this before, let's just do a reminder in numbers of putting two fractions on a common denominator. Let's say we've got 7 over 5 minus 3 over 4. And if we were to put that on a common denominator, our common denominator would be 5 times 4. And we would go through the routine. How many times does 5 go into 5 times 4? Well, it goes 4 times. And we multiply that by the numerator of the first fraction, multiplied by 7. Here's our negative sign. And we then go through the routine with this fraction. 4 into the denominator of 5 times 4 goes 5 times. And that's multiplied by the 3. And then the rest will be tidying it up arithmetically and finding an answer. But notice a few things here. Look what's happened to the original denominator here. It started off down there, now it's part of the denominator, and then it pops up here, multiplied by the original numerator here. And look what's happened to the 4. The 4 started off here, it's become part of the denominator, and it's ended up here. And that's exactly the same that's going to happen with this expression here. Let's just do the comparison, and you'll see. Okay, there are the original two terms. Let's set up a common denominator, and the common denominator will be the two terms multiplied together, just like we did the numbers. So this is y minus 3 multiplied by 2y plus 1. Go through the routine. Y minus 3 into the denominator leaves a remainder of 2y plus 1. And that's multiplied by the original numerator up here, which is 2y minus 3. Here's our big minus sign, that one there. 2y plus 1 into the denominator leaves y minus 3. And that's multiplied by the original numerator up here, 2y minus 1. And exactly the same thing has happened. Here is y minus 3. It's appeared in the denominator, and it's appeared here. And here is 2y plus 1. It's in the denominator, and it's appeared up here. It's exactly the same pattern as with the numbers. Okay, what we've now got to do is we've got to multiply this thing out. And we're multiplying two brackets out, so we're going to have to use the eyebrows and smiles technique of multiplying each term by the other pair. Okay, let's just start. 2y times 2y is 4y squared. 1 times negative 3 is negative 3. This first multiplication here is plus 2y. And this second multiplication here is negative 6y. So I'm popping our minus sign in there, but I'm popping all the results I'm going to do in a big bracket because I know I'm going to have to multiply by the negative sign out the front here when I come to write the next line. So let's just do this ignoring that negative sign out the front. Y times 2y is 2y squared. Negative 3 times negative 1 is positive 3. And this first underneath multiplication is negative 6y. And this second one is negative y. And that is all over our unchanged denominator of y minus 3, 2y plus 1. Okay, we've got to write all this lot out again, this time changing the sign of all these guys. And I'm going to mix the two sets of y terms as I go. I might as well simplify something. So we get 4y squared minus 3. These two together is negative 4y. Then we get negative 2y squared. Minus times the positive 3 gives another negative 3. So negative 6y and then another negative y is negative 7y, but it becomes positive 7y when that has a go at it. So plus 7y. Okay, now we can put these two guys together. We can put the y's together. And we can put the numbers together. And we get 4 of these take away 2, leaves 2y squared. Negative 4y adding positive 7y is positive 3y. and the two numbers -3, -3, -6. And this once again is all over. And that happily matches what the question has suggested. So that is the answer. But we've still got to do part B. And what's it saying? Hence or otherwise, don't ever do otherwise. Hence, solve the equation that. What we notice is that the left-hand side of this equation is exactly the same as what the question has started with. The question is hinting that if we make this equal to 1, we'll be able to solve and simplify very much more easily. So let's just set that up. Well, the trick now is to get everything on the same line. If we multiply both sides of the equation by the denominator, on this side they will cancel and they will appear multiplied by 1 on this side. So we get 2y squared plus 3y minus 6 is now equal to y minus 3 multiplied by 2y plus 1. So we've now got to multiply this pair of brackets out, again using the eyebrows and smiles technique, and simplify. So left-hand side copy and paste is equal to, the first two is 2y squared, -3 times +1 is -3, this gives -6y, and this gives a positive y. Well, straight away, before I do anything else, because we've got 2y squared on both sides of this equation, they will cancel each other out. So I've got 3y minus 6 on this side, and on this side, these two will merge. So I get -3, and -6 plus a y is -5y. Now I want the y's onto the left of the equal sign, and the numbers onto the right. So the 5y, we're going to add 5y to both sides. So I get 3y plus 5y, it having moved, -6 is equal to -3. Now we need to get rid of the 6 by adding 6 to both sides, and we get 8y is equal to, well, adding 6 to both sides means this one disappears and we add 6 onto this side. -3 plus 6. So 8y equals -3 plus 6 is 3, and y equals, we can do no more moving, we just have to divide both sides by 8, which means it cancels on this side, and we just get 3/8 on this side. And that, if I've done the arithmetic correctly, is the answer.